Okay. So in these two tests performed on the single phase transformer, we are able to find out the equivalent circuit parameter. What are the advantage here? Performing the open circuit test and a short circuit test on the transformer. So these two tests on a transformer help to determine the parameters of the equivalent circuit of the transformer, voltage regulation and efficiency. Okay. So complete analysis of the transformer can be carried out when its equivalent circuit of the parameter we obtained. Okay. And the power required during these two tests is equal to the appropriate power losses occurring in the transformer. You know that maybe two types of losses take place. One is your core loss, another is your ohmic loss. Okay, resistance. So total losses, if we obtain, then we are able to find out the efficiency of the transformer. So just try to see how we can connect the transformer with the instrument or supply during the open circuit test. Okay. So what is the meaning of open circuit test? Can you tell me? Open circuit test. What is the open circuit test? Anyone? Open circuit test, or maybe it is also known as the no load test. No load test, that means no load on the transformer. We are not connected any load towards the secondary side of the transformer. Okay. So only the supply given to the primary winding and secondary side of winding is open or no load. So, okay. कोई भी हम लोग लोड कनेक्ट नहीं कर रहे हैं. During this period, that means open circuit test, when we supply given to the transformer, then what will take? Some power will be drawn from the supply side, is it not? So how we can connect the transformer for the no load test? No load test, just you maybe observe that the circuit diagram, when you perform the test, that means we already mentioned that the transformer consists of two winding. One is your LV winding or HV winding, depends on the number of turns. Okay. So when we are going to perform the open circuit or no load test of the transformer, then instrument, this what are the instrument we have connected that across the LV winding and HV winding kept open. Okay. So through the supply, AC supply, that means this is your AC supply, may be represented as sinusoidal voltage V with the barrier. Okay. That means primary winding connected or LV winding connected with the instrument and supply, and HV winding kept open. Okay. So no load test or open circuit test performed on the rated voltage and rated frequency. One point you have to get. Okay, that is rated voltage and rated frequency. So supply given with the help of a variable AC source and 1 voltmeter. You have to connect here in the parallel. So maybe represented as with the voltmeter with V, and 1 watt meter. That means whatever the power consumed during the no load test, that will be measured with the help of watt meter, and 1 ammeter connected for the measurement of no load current during the no load test. Okay. तो यहाँ पे हम लोग कौन कौन सा रेटिंग नोट कर सकते हैं? तो जब ओपन सर्किट टेस्ट हम लोग परफॉर्म करें, दैट मीन्स रेटेड वोल्टेज जो भी होगा एलवी वाइंडिंग का ट्रांसफार्मर का, वो हम लोग विद दी वेरिएक इसको पोजीशन एडजस्ट करते रहेंगे. ओके. and continuously measure with the help of one voltmeter connected parallel here. Okay, when the voltmeter indicate the rated voltage of the LV winding, then we stop the movement of this barrier. Okay, and at this point we recorded all the instrument reading. That means one voltmeter reading, wattmeter reading, and ammeter reading. Okay, these three instruments are connected here. So at the rated voltage, we record all the instrument reading. Okay. So what is indicate the voltmeter reading here? That means rated voltage of the LV winding, is it not? And power consumed during this period, that is indicated by the wattmeter, and current measured by the ammeter. So this current is equal to no load current, is it not? Since this secondary side is HV side is open, that's why it is known as the open circuit test. Okay, that means no load connected through this coil. So what are the various components we can find here? That means wattmeter reading given to you whatever the power consumed during the no load test, and ammeter reading given to you no load current. Okay, so during this period we just consider the wattmeter reading as the core loss of the transformer, since the ohmic loss is very small compared to the full load current, since the no load current of the transformer is required only 2 to 6% of the rated current. So ohmic loss may be neglected comparison to the core loss, since the current is vary 2 to 6%. So ohmic loss you may be 0.04, that means I square R, is it not? Ohmic loss is I square R. So I, if you vary with 2 to 6%, that means ohmic loss is your 0.04 to 0.36% of the rated no load current. So comparison to that, during the open circuit test, we only consider the wattmeter reading as the core loss. Okay, since the core loss is directly proportional to the square of the voltage, and no load current is very small compared to the full load current. Okay, so this point is clear to all of you. That means a no load voltage we have obtained from the voltmeter reading, and core loss power with the wattmeter reading, and no load current through this ammeter. Okay, so if these three data we note down, then we can just put on the formula for the core loss. We already in the previous class explained that one. That is what is the core loss power, can be represented? कैसे represent कर सकते हैं? Remember, if you recall the phasor diagram also, or power equation, core loss nothing but can be represented as the Vi cos theta. That means V1 into no load current into cos theta 0. Okay, V1 into no load cos theta 0. Okay, so the circuit diagram is whatever I have explained in the previous diagram, that is here described. That means how we can proceed the open circuit test. Okay, and how we can consider the wattmeter reading as the core loss. Okay, and ohmic loss is neglected during the core loss. So only consider the core loss of the transformer using the no load test. Okay, since the no load current we already mentioned that small, so just maybe simplified diagram, since the primary side impedance drop is negligible, very small, so that can be neglected and simplify the circuit just like this one. Okay. If we primary leakage impedance drop, that means R1 X1. यहाँ पे हम लोग क्या शो किए थे, R1 X1 parallel to that one RC and XM. RC is your core loss resistance and XM is your magnetizing reactance. Okay, so if we primary leakage impedance drop is almost negligible, since the current, no load current is very small compared to the full load current. Okay, so simplified diagram may be represented like this one. So just we consider that means the input power given by the wattmeter reading consists of core loss and ohmic loss. So ohmic loss is neglected due to the very small no load current compared to the full load current. Okay. I think it clearly visible or not? Hello. Hello, Manish.
Yes, sir.
Is it clearly visible?
Yes, sir. It's visible.
Okay. So I think can you read out? So V1 is nothing but the applied rated voltage of the LV side. That means a low voltage side. Okay. And exciting current or no load current is represented by IE. Okay. And core loss power is represented by P suffix C. So core loss is nothing but VI cos theta. Okay. So V is your V1 and I is your I exciting IE cos theta 0. Cos theta 0 is no load power factor. Okay. So no load power factor can we find out from this equation, because you are already taken the reading of wattmeter and voltmeter current, ammeter. So if you put all these parameters, that means power, voltage and current, then we can find out the no load power factor of the transformer, is it not? Cos theta 0 equal to PC divided by V1 IE. Okay, so PC, that means core loss, you can obtain from the wattmeter reading, is it not? And applied voltage with the voltmeter and no load current with the ammeter. So whatever you reading note down from the wattmeter and voltmeter and ammeter, just put here. Okay, and find out the no load power factor, that means cos theta 0. So if we able to find out cos theta 0, is not, if we find out the cos theta 0, then we are also able to find out sin theta 0. कर सकते हैं ना हम लोग, यदि cos थीटा 0 का वैल्यू पता है तो sin थीटा 0 हम लोग कैलकुलेट कर सकते हैं। कितना लिख सकते हैं हम लोग sin थीटा इक्वल टू cos के टर्म में? कोई नहीं बोल रहा है। sin थीटा
sin 90 minus theta से
डायरेक्ट sin स्क्वायर थीटा cos स्क्वायर थीटा इक्वल टू 1 लिख सकते हैं ना हम लोग।
यस सर।
sin स्क्वायर थीटा प्लस cos स्क्वायर थीटा इक्वल टू 1 ट्रिग्नोमेट्रिकल फार्मूला से। तो sin स्क्वायर थीटा इक्वल टू क्या sin थीटा इक्वल टू क्या लिख सकते हैं, स्क्वायर रूट ऑफ 1 माइनस cos स्क्वायर थीटा लिख सकते हैं कि नहीं?
यस सर।
तो sin थीटा 0 का वैल्यू कैलकुलेट कर लिए, cos थीटा 0 का वैल्यू कैलकुलेट कर लिए। तो कोर लॉस करंट IC कितना होता है इन टर्म्स ऑफ डायग्राम? I इक्वल टू क्या होता है, एक्साइटिंग करंट दैट मींस नो लोड करंट इज द वेक्टोरियल समेशन ऑफ द core loss current plus magnetizing current, is not? Or maybe if you from the phasor diagram, if you break the core loss current that is represented by IC and IM along the phasor phi. So IM equal to nothing but no load current sin theta 0 and IC equal to along if IE, that means no load current, if you take along the IE and IC, then we can represent that means IC IE cos theta 0 plus and IM equal to IE sin theta 0, is not? So it is again the same things, I think. So IC can we find out because we already note down the reading of emitter that is represented the IE and cos theta you already find out here. So just if you put the value of cos theta 0 and IE, that means no load current, whatever your emitter so reading, that if you put here, then you will get the value of IC, that means core loss current. And similarly, we can find the value of magnetizing current IM, that means IE into sin theta 0, is not? So with this cos theta 0, we can find out sin theta 0 and put the value of here. So now, or otherwise we can directly write here IC equal to how much? Core loss if cos theta 0 equal to theta 0 at the no load, if you consider almost tends to 0. Okay. If you almost tends to 0, no load power factor is very near to 0. So that the IC equal to PC by V1. So core loss resistance, that means RC. How we can find out RC? RC equal to कितना लिख सकते हैं हम लोग इस फिगर से? RC equal to कितना लिख सकते हैं? इस फिगर से suppose that this voltage is your V1 and I exciting current flowing through this one. So along this side, your current is flowing how much? IC, and along this side is flowing IM. So RC equal to हम लोग कितना लिख सकते हैं? Voltage by current, is not? Simply, if you apply the Ohm's law here, that means V equal to IR. So V1 equal to ICRC, is not? So RC equal to how much? V1 by IC. And similarly for this one XM, how much we can write here? कितना लिख सकते हैं?
V1 by IM.
V1 by IM. Okay. So you already find their value of IM and IC. So just put on this equation and just calculate the core loss resistance, that means RC, and magnetizing reactance XM. Okay. So V1 by IC, and if you simplify this one, we will put this value, that means V1 by IC equal to nothing but IE exciting or no load current into cos theta 0. And similarly for the XM, that means magnetizing reactance. Okay. So V1 by how much? IM. So you can write here V1 by IE sin theta 0. Okay. So we can find out two parameters with the help of open circuit test. Is not? Core loss resistance and magnetizing reactance. हम लोग फाइंड आउट कर सकते हैं कि नहीं? हेलो.
Yes, sir.
ओके. तो हम लोग को ध्यान क्या रखना है इसमें ओपन सर्किट टेस्ट परफॉर्म करने के लिए? कैसे परफॉर्म करना है? कौन कौन सा पैरामीटर हम लोग फाइंड आउट करते हैं ओपन सर्किट में, एंड हाउ वी कैन connect the instrument with the winding. That means all the winding connected towards the LV winding and HV winding kept open. And these are the mathematical calculation for the core loss resistance and magnetizing reactance. So up to this point, is it clear to all of you? So
Yes,
whenever we perform the no load test of the transformer, we just concern about the connection of the instrument. Okay. This side we required to connect all the instrument. So which are the various type of instrument required for the नो लोड टेस्ट ऑफ द ट्रांसफार्मर? कौन कौन सा इंस्ट्रूमेंट हम लोग को चाहिए? नो लोड टेस्ट परफॉर्म करने के लिए कौन कौन सा इंस्ट्रूमेंट चाहिए? यदि हम लोग नो लोड टेस्ट परफॉर्म करना चाहते हैं तो पूरा तो अभी एक्सप्लेन किए जस्ट। यदि हम लोग
एमीटर सर,
एक एमीटर चाहिए
और एक वाट मीटर सर,
वाट मीटर
और लो वोल्टेज सर ट्रांसफार्मर।
लो वोल्टेज नहीं, दैट मींस सिंगल वाइंडिंग तो एग्जिस्ट नहीं करता, ट्रांसफार्मर चाहिए तुमको। ओके, ट्रांसफार्मर में दोनों वाइंडिंग रहेगा, लो वोल्टेज वाइंडिंग भी रहेगा और हाई वोल्टेज वाइंडिंग भी रहेगा। तो क्या चाहिए? एक ट्रांसफार्मर चाहिए तुमको, इज नॉट? एक ट्रांसफार्मर चाहिए
और एमीटर और वाट मीटर।
एमीटर, वाट मीटर, वोल्ट मीटर और एक ट्रांसफार्मर। और क्या चाहिए? तुम्हारे पास एमीटर भी है, वोल्ट मीटर भी है, वाट मीटर भी है और एक ट्रांसफार्मर भी है। Then are you able to perform the no load test on that transformer, or you required some other things? Any missing
और
things?
पावर चाहिए सर।
Power चाहिए, exactly. So we required 5 things. That means one transformer, one voltmeter, one emitter, and supply, and one auto transformer or barrier. Okay, one auto transformer or barrier, maybe known as the variable transformer. If all these instruments you have, then you are able to perform the no load test on the transformer. Okay. Next, suppose that you have all these things. Next, how you connect all these voltmeter, ammeter, and wattmeter, and which winding you have to connect? Transformer. So you have to keep in your mind, the no load test is always performed on the LV side. Okay, because this test perform on the rated voltage, so you have to perform on the LV side and HV side kept open. Okay, so all the instrument and supply you have to given through the LV winding. And what is the procedure performing this test? If you connect all the instrument, then what is the procedure? मेन ध्यान क्या रखना पड़ेगा? जो ऑटो ट्रांसफार्मर का वेरिएबल पॉइंट है उसको चेंज करते रहना है, एंड वाट वोल्टमीटर का जो रीडिंग है उसको ध्यान में रखना है कि वोल्टमीटर रीडिंग if indicated rated value of the LV winding of the transformer, whatever the transformer rating of the LV side, you have to concern about that point towards the voltmeter and accordingly change the auto transformer variable position. Okay, whenever you got the rated voltage of the LV winding through the voltmeter, then you stop the movement of auto transformer variable point, and At that instant, you have to note down all the instrument reading. Okay, that means voltmeter, ammeter, wattmeter. And if the instrument reading note down, then your next part is your left calculation. That means finding the parameters of the RC and XM. So this is the procedure we have already explained how we can find the RC and XM. Okay, if you note down the reading of ammeter, voltmeter and wattmeter, then you have to just simply calculation just RC and XM. For the calculation RC and XM, that means core loss resistance and core loss magnetizing reactance, that means XM. Okay, so these two parameters of the transformer we can find out with the help of no load test. Okay, so I think is it clear to all of you, or have any doubt? Just ask me. Otherwise, we will move to next test, that means short circuit. Okay. So we shall we move for the short circuit test, or have any problem? Just tell me.
No problem, sir.
Okay. So can we move for the short circuit test? Okay. So basically all the same instrument we required for the short circuit test. Just only we concerned about the short circuit test is that we have performed the short circuit test on the rated current of the transformer. And one more things, yeah. So short circuit test we just perform on the rated current. Okay. So for the rated current, we have to just connect all the instruments towards the HV side and LV side kept open. Just reverse to the no load test. Okay. So connection is just reverse to the no load test. That means whatever the instrument we require for the connection of performing the short circuit test is connected towards the HV side. Okay. So this is the connection for the short circuit. That means all the instrument, that means ammeter, voltmeter and wattmeter, we have connect with the HV winding of the transformer. Okay. And LV winding is sorted with one wire. Okay. So LV winding is short circuited. So again, you have to change the variable point of this variac auto transformer. Okay. And you have to concern, instead of voltage reading, we concern here current reading. Okay. During the short circuit. So whenever the rated current flow through this ammeter, we just stop the movement of this auto transformer. Okay. So simply you can do first of all, if any data given to you upon name specification of the transformer, then I think you are able to find out their LV side and HV side current. Okay. So whenever the rated current of the transformer is flowing through this ammeter, then you just stop the movement of this auto transformer. You know, and at this instant, you have to note down all the reading of the instrument. That means ammeter, wattmeter, and voltmeter. Okay. So because the no load short circuit test is connected across the HV winding, because the short circuit current is flow almost a very small voltage rating. That means we can say that the almost short circuit test I think how much? Yeah, short circuit current or full load current flow is required only almost 2 to 12% of the rated voltage. Okay, so whatever the voltage rating of the HV side winding, so only required how much? That means 2 to 12%. Okay, and 2 to 12% is almost at that instant rated current flow. So that the standard instrument we maybe find out in the laboratory because suppose that uh, 230 volt and LV side is your 110 volt. Okay, so 12% of that 220 or 30 volt is only required for the rated current flow in the HV side. Okay, so at this instant during the short circuit period, we just consider the ohmic losses of the transformer and core losses is negligible because the voltage is very less required, just similar to the reverse of that no load test that I have explained for the core loss, that means a square of the applied voltage. So only the 2 to 12% voltage is required for the rated current. So core loss is neglected during the short circuit test, and whatever the reading we have taken here, so that is nothing but the ohmic loss of the transformer. Okay. So this is the in the circuit diagram representation. We have just R1, X1 and X2, R2, and this is your RC and XM during the short circuit. So secondary side just sorted. And this is your systematic diagram and connection. This is your circuit diagram in the equivalent circuit at the short circuit. Okay. So and this part you may be omitted because the core loss is not considered during the short circuit period because the applied voltage is very small, 2 to 12%. So you